Human language is incredibly messy. Every day we throw around questions, commands, and emotional outbursts. But to systematically test if an argument holds up, we need strict order. That is the purpose of formal logic. It acts as organized sense-making. To make sense of the world, we must start with an undeniable foundation. This graphic defines our core building block, the statement, a sentence that is strictly true or false. We ground this using variables. It is sunny today becomes variable P, and we will play soccer becomes variable Q. By isolating these statements, we translate messy reality into a precise, testable mental landscape. Isolated statements don't exist in a vacuum. Human interactions require combining them. We need a way to track the truth when these ideas get tangled together. This table shows the abstract symbols for the basic logical operators, and, or, and not. Look at the first two rows. And demands perfection, true only if both pieces happen. Or is much more forgiving, true if one, the other, or both occur. The not operator acts as a logical mirror. It simply reverses the current truth value of whatever statement it's applied to. These basic operators are the mathematical laws governing how all our ideas interact. We can combine these variables to map a very human interaction, a promise. We call this a conditional statement. If P, then Q. Let's test a specific promise. If it is sunny, then we will play soccer. How do we mathematically prove exactly when this rule is violated? Here is the truth table for that implication, visually mapping every possible reality. There is exactly one scenario where the promise is broken, highlighted in red. The rule fails when it is sunny, P is true, but soccer is canceled, making Q false. What about the cloudy day edge case? If we play soccer on a cloudy day, P is false, but the rule isn't broken. Our original promise only governed what happens on sunny days. Logic defends common sense. It pinpoints exactly when a rule is violated, while ignoring scenarios where the rule was never activated in the first place. Once we map a promise logically, we can translate it into entirely new phrases without ever changing its core truth value. This chart demonstrates the equivalent form. Notice how the truth columns perfectly match for if P then Q and either not P or Q. Saying if it is sunny then we play soccer is mathematically identical to saying either it is not sunny or we play soccer. We do have to be careful of a common mental trap called the converse. This is the human fallacy of assuming rules work backwards, assuming that if we are playing soccer, it must be sunny out. The converse is a dangerous assumption. We could easily be playing soccer in the pouring rain without breaking the original rule. To create a flawless logical mirror, we use the contrapositive. By both reversing and negating the statements, we construct a new rule. If we do not play soccer, then it is not sunny. This formulation perfectly preserves the truth of the original promise. Propositional logic is an incredibly practical tool. By breaking language down into testable rules, it gives us a reliable defense mechanism to navigate the claims and promises we encounter every day with absolute clarity.